Hello and welcome to this new installment of Built-in Public chess game. My name is Moises, and in this fourth episode we are going to finish the pieces movements programming the pawn. Let me create first the files for the pawn class and their specs. This is going to be the pawn class, and this is going to be the spec file for the pawn. The pawn class will inherit from the piece class as always. Let me create here empty methods for the abstracts. One for the directions method. And another one for the value method. Okay, let's go now for the specs, the requirements. And let me copy here the new specs. We are going to check that the new pending specs are there. Okay, they are. So that's it. Okay, let's start with the first one. We are going to check that we can move the pawn forward 1 or 2 squares. This forward direction depends on the color of the piece, so we have to take it into account in some way. We are going to create this board factory, pawn in start position, in order to recreate a board with pawns in their start position. Let me create here the static method for the factory. We are going to pass it a pawn as an argument in order to put it in the board. Let me create here an empty board, and we are going to return the board itself. So as I told you before, the movement will be different depending on the color, so we have to check if the given pawn is black or white. So I'm going to use this method, white question mark here, that it's not implemented, so we are going to put it into the piece class, and all the pieces could call it when it's needed, not only the pawns. We are going to create the white question mark method. Here we are going to check the color, and we are going to return a boolean, and we are going to create the black question mark method as well in order to make it more usable. Okay, since we have created a couple of new methods, we are going to provide tests for them. So these tests are very simple, so I'm not going to spend time here, so let me copy them, and that's it. We're going to test it, and green, perfect. So we can go back to our factory, and now we can use the new methods. If the given pawn is white, we are going to place it in the 6-3 position. And for the black one, we are going to place it in the 1-3. 1-3. That's it. Okay, back to the specs. Our expected target squares for the black pawn should be 1 or 2 squares forward. That's it. 2-3 and 3-3. Remember that the initial position is 3-1. Here we can see the movements of the 2 pawns. For the black one, we can move 1 or 2 squares in that direction, and for the white one, the same but in the opposite direction. Okay, let's finish the test. The pawn possible movements should contain the expected target positions. We run the tests and we get an error because the directions method is empty. So let's go with the implementation. We have to return here a double array of positions. So I'm going to move the logic to a private method in order to keep things simple. Let's call it forward moves, just like that. I'm going to return the relative positions taking into account that they are different for blacks and whites. I'm going to create this variable here to store the possible relative moves. I'm going to return it at the end of the method, and I'm going to put it here in the directions method, forward moves. And now we have to check the direction of the pawn. If it's white, is in one direction, and if it's black, is in another one. So in the case of the whites is -1 0, and in the case of the blacks 1 0. Let's run the tests, and they are failing because we are expecting two squares, two different possible moves, for one square and for two squares. I'm going to create another private method called first move ? To check this condition. Since the pawns could only move forward until the end of the board, we could assure that the piece is in its first movement if it is in the initial row. That's it. That's it. 1 for blacks and 6 for whites. We are going to get the position of the given piece. We are only interested in the row 1. So in the case of the whites, we are going to check that the row is 6, and in this case we are going to return true. And for the blacks, we are going to check if it's in the row 1, and we are going to return false in other case. Okay, now we are going to append another relative position to the moves array depending on the color of the piece. -2 0, and 2 0. And if we run the tests, they are passing. So let me refactor a bit this code. We are going to use here a compound conditional that checks both conditions at the same time. This should work. Let me test. Okay, and now we are going to use ternary operators here, just to make it a bit cleaner. Okay, that should work. Let's check it. And all green. Okay. Now we have a little problem because other pieces, capture pieces, will they move, but the pawn is a little different. They only could capture pieces in diagonal, not while moving forward. So we have to check that we are respecting the rules with that test. Okay, we are going to put a random piece in front of the pawn. So in this specific case, the pawn could not move at all because we cannot capture the piece that we have in front. Let's run the tests, and they are failing because we are not applying the rules correctly. Since the pawn attacks in a different way, I'm going to override the possible moves method in the pawn class just to apply directly the specific rules for this piece. As I told in the previous video, the pawn has very tricky movements. So if we recreate here the possible moves method with the same signature and return and everything, every time that we call possible methods on a pawn, this method is going to be used instead of the inherit class. So we are going to check the rules for forward moves here. We are going to do the same as we did in the possible moves from the piece class, to loop over each of the relative moves. Let me check in the piece class what we did. I'm going to copy this code here because we are going to change it a bit. Okay. We are calculating the relative move. Instead of initial pause, we are going to put here row and call, that it's a bit clearer. And we have to we are checking that this is a valid move. We are going to see what happens in that method in the board class. Let's go to the board class. Let's find the method. Here is, we are checking that the movement is in bounds, the target is nil, or the target is not nil, but the color is different from the piece itself. So that's the problem. We have to check that the movement is in bounds. And the board is empty. Well, the board is empty now. The target square is empty. Okay, if not, we are going to break and we are going to run the tests, and it's failing because the inbounds method is private. We are going to make it public, and as well we are going to make tests for that method because now it's public. I'm not going to spend time doing it. I'm going to copy it. So that's it, and we are going to run the tests again. And now are passing. Okay, we can go back, close all these buffers, and we can go again to the tests. And since we finished that block, we are going to copy it in order to test the white piece. Let me change black for white. Black for white, okay. Let me check that everything is okay. Okay, we have to change that for black as well. And I think that's all. Let's run the tests, and they are failing, so something is wrong. Okay, let's back to the test, and I think that yes, these expected positions are wrong. We have to change it for the white pieces, and as well this has to be a minus instead of plus. Okay, and now it's running. Okay, let's go now for the movement of non-start position. In this case, we are going to build a new factory for the board. Pawn in non-start position. let me create the new method in the factory. We are going to pass as an argument a pawn as well. So let me copy the logic from the above, and we are going to change the positions. In this case, we are going to move the pawn one row in each case, 5 and 2. Okay, and let's go back to the test. Okay, and in this case, pawns should move only one square in each direction. So let's go into test that. The possible moves should be only one. And should be 3-2 in the case of the black pawn. Let's run the tests, and it's okay. So we are going to implement the next test. Should not capture piece in front as well as we did before. So we are going to manually put a piece in front of the pawn. Of the opposite color, in this case white. So I'm going to use the relative positions in order to put the piece in front of the pawn, and I'm going to test that the possible moves are empty. Okay, we are on the tests, and they are passing. Okay, so again we are going to copy that block and change things to test the white pawns. So we are going to change black for white, and we are going to change the this color, and this should be let me run the tests, and they are failing because I did the same mistakes as before. So let me change that, -1, and another error, and that's because I forget to update this position as well. So now we're passing. Okay. Now I'm going to test the capture. So in this case, this pawn could capture in diagonal these two pieces and could move forward as well, one square. So we are going to build a new factory, pawn in attack. In order to test that, we are going to create a new factory method here. We are going to pass a pawn as an argument, and we are going to configure the board as we seen before. Okay, let me create here this argument here, same color, in order to change the color later, to check that one pawn cannot capture pieces of the same color. So here we are going to select the color of the pieces that we are going to put in the diagonals of the pawn. And we are going to create two random pieces, other one and other two. We are going to use the piece factory random, and we are going to create it of the color that we select. before. So now we are going to put this other one and other two pieces in the diagonal positions, depending on the color of the given pawn. So this is the position for the other one piece. The other two, that should be +1, -1. I think that it's okay. And in the case of the blacks, +1, +1, and -1, +1. Okay. I think that it's okay, and we are going to test that everything is okay. So possible moves of the given board should equal to 3, because 2 captures and one movement forward. So there is an error here. We have to change that constant. There is another error. Okay, let me check what could be. It's the name of the function or the method. So let's run the tests, and this is okay. It's failing because we are not implement the attack or the capture movement. So we are going to create another private method here, attack moves. We are going to put it here as well. It's not needed in this case, but we are going to put it as well. And here we are going to check the attack movements. So again, we are going to differentiate between whites and blacks. This is the relative position in the case of the whites, and in the case of the blacks it should be 1, 1 and -1, 1. Okay, let's go here to implement the checks. Okay, as we did before, we are going to copy that because it's the same. And in this case, we are going to add it to the valid movements if it's a valid capture. The movement is a valid capture. We are going to create a new private method here in order to check if it's a valid capture or not. Board and position, and this is going to return a boolean. Okay, what is a valid capture? If the movement is in bounds, first of all, and the target position is not empty, that means that it contains a piece, and that piece is from other color than the given or the actual pawn. That's a valid capture movement. So we are going to run the tests and everything it's okay. So let's continue. Should not capture piece of the same color. Okay, we are going to test the same movement, but changing the color, putting in the diagonals of the pawn pieces of the same color of the given pawn. So for that we create before the same color variable. We are going to put it as true here. And if we check the possible moves, this is going to be 1 because it's the forward movement. So if we run the tests are passing. So we have again to clone or copy and paste this block here and change it for the white pawn. That it's the same but in different relative positions. So let me test it, and everything it's okay. So we'll go for the last test that should test the value of the pawn. That should be equal to 1. So, okay, we're going to create a pawn. It doesn't care the color because always have the value of 1. If we implement that value method here and we put a 1 and run the tests, and that's it. Okay, I'm going to add something that I almost forgot, that it's include the pawn piece in the pieces array here. And now we are going to close all the buffers, run the tests again, and we are going to implement that pending test. Okay, let me open the board spec class. Let's going to open it here, and we are going to enable this test again. Remember that test is the one that set up a new game. If you remember, we were using the piece class. Instead of that, we are going to put the real pieces here. We are going to create a new rook, and we are going to create a bishop as well, another bishop here. No, this is a knight, sorry. It's a rook, knight, and then go for the bishop, and then queen and king. Queen and king. Okay, we are going to put it in the right positions here. 0, 1, 2, 3, 4, 5, 6, and 7. And this row is going to be pawns, the black ones, and we are going to copy that. Yes, we are going to copy that in order to create the white pieces as well. Let me change make black for make white. And we are going to change the positions as well. 0, no, 7, 7, 7, 7. And let's run the tests. Yeah, we did it. 135 examples and less than 5 milliseconds. Okay. So that there are a couple of things missing. We are going to note it in this to-do file. For example, something that is missing is the pawn coronation, coronet pawn or pawn promotion. Another thing that it's missing is the en passant, or something like that. Sorry for my French. That it's a very, very special movement of the pawn and the king castling. Yeah, that's it for today. In the next episode, we are going to learn how to make a nice graphical UI in order to see the board and the piece movements. Yeah, that's it for today. See you in the next episode. Bye.